What's up everyone, welcome back. Patrick here, and moving on to the next video, we got to simplify these two expressions. So starting with number 1, we got the third root of -8 m to the 6 n to the 9 all over the square root of 64 m to the 4 n to the 12. So first thing I'm going to do is I'm actually going to take these radicals and change them to rational exponents. That's personally what I like to do. So as we know, if we have the nth root of something, well, that's the same as that something to the power of 1 over n. So here we could change this to be -8 m to the 6 n to the 9. That's like this a here, all to the power of 1 over 3. And then with a square root, there's like an imaginary 2 there. So I'm going to take 64 m to the 4 n to the 12 and take that to the power of 1 over 2. The reason why I like to do that is because here now I like to use exponent rules to simplify this. So notice we're multiplying -8 m to the 6 n to the 9, and that's all to the power of 1 over 3. So what we can do is we could take each of those expressions to the power of 1 over 3. Like that. And then same thing over here. The 64 would go to the half, n to the 4 would go to the power of a half, and then n to the 12 would go to the power of half as well. And then -8 to the power of 1 over 3, the third root of -8 is -2. Here we would just multiply these exponents. 6 times 1 over 3 is 2. 9 times 1 over 3 is 3. All over the square root of 64 is 8. 4 times 1/2 is 2, and then 12 times 1/2 is 6. And so then notice that this here, what's it going to simplify to? Well, -2 over 8, that would give us -1 over 4. Let's keep the fractions separate for now, and then I'll give another answer where we combine them. So we got -1 over 4. Notice the m to the power of 2's cancel out. Right? Or if we subtract these exponents, 2 minus 2 is 0, and to the power of 0 is just 1. So it goes away. Then we have 3 n's at the top, 6 n's at the bottom, meaning we're left with 3 n's at the bottom, like that. And because the n to the 3 was at the bottom, then I already made it together with the fraction, because it'd be weird to kind of write it as that. Right? But if the n to the 3 was at the top, that would be one way to write it, and then that would be one way to write it. Because it was at the bottom, there's really only one way to write this. It's like that. So all of this here simplifies to that right there. And then moving on to number 2, same thing. We're going to do the same process. We got the fifth root of 243 m to the 10 n to the 15 over the third root of 64 n to the -3 n to the 6. So I'm going to take this expression, rewrite it, but then that radical I'm going to change to a rational exponent. Same thing here. This would be to the power 1 over 3, like that. And then each term is going to go to that respective exponent. And then at the bottom, we'll have 64 to the power of 1 over 3. We'll have m to the -3 to the power of 1 over 3. And then we'll have n to the 6 to the power of 1 over 3, like that. So then same thing here. What is the fifth root of 243? Well, that's going to be 3. 10 times 1 over 5 gives us 2. That's going to be 3. All over the third root of 64 is 4. -3 times 1 over 3 gives us -1. And then 6 times 1 over 3 would give us 2, like that. So then 3 over 4, we can't simplify that any further. Now this m to the -1, what I'm going to do is I'm going to bring it up to change it to a positive exponent. So we would have 3m to the 1 m to the 2. And then the n to the 3 over n to the 2, that would simplify to just n to the 1 at the top. 3 minus 2 is just 1. And then that's going to be all over 4, like that. And then these two we could simplify. They're the same base, so we could add the exponents. So that would be 3m to the 3 n over 4, right? The 1 we don't have to write. So it could be written like that, or another way is you can take out the fraction, the 3 over 4, and then we'll have m to the 3n, like that. So two different ways to write it. Another way you could have simplified the m's here is 2 minus -1, which would be 2 plus 1, which would be 3. So that's how you'd get that there. But either way, that is what the final answer is.